Hi guys, welcome to another video based on graphing quadratic functions. I hope that you'll enjoy the video and make sure that you subscribe and share the video with others. So when you think about the quadratic functions, you are thinking about the equation that looks like this, which is very important to understand how A, B, and C works. So remember that the standard form of quadratic function looks like this, and this is actually important when it comes to drawing the graph, or maybe I can say the positive graph. If A is greater than 0, then it means that the graph itself will definitely be incrementing, right? So the graph will definitely increment, and also when the value of A is negative, it means that the graph will decrement. So this is very important in terms of understanding how the value A can actually affect the look and feel of your graph, right? So just to continue from that, we can actually talk about the line of symmetry, which is very important when we are drawing these graphs, because we do have like a turning point. We do have a turning point as a vertex, and you know what it is because I have other videos based on that, right? So going forward, we can actually talk about the line of symmetry and how we can be able to draw the graph with that line of symmetry at the middle. So this will definitely be the turning point of the graph, right? And as the turning point, we do have some formulas that we can be able to use in order for us to get the line of symmetry, or just the turning point in general. So yes, we do call this line the line of symmetry, and it's actually vital because we are able to know that we have a turning point per each and every single graph, regardless of the fact that it's negative or the graph is positive. So the line of symmetry always passes through the vertex, and the vertex will definitely be this particular point here, right? So let's see how we can be able to get the formulas to calculate the vertex. So now we have the quadratic as given, and with this it means that we can be able to think about how we can be able to calculate the values of vertex, or maybe the turning point, right? The equation of the line of symmetry is given by this formula here, and we know that x is equal to negative b and then divided by 2a, right? And that's very important because with this formula we can be able to get the vertex, we can be able to get the turning point, because it's actually the same thing. So remember that we have our A and we have our B and we have our C. So the only thing that we took here was actually 18 and also the value of A, and the value of A will be 3, and then the value of B will be negative 18, meaning that negative 18 multiplied by negative 18, we are getting a positive 18. And with all that, we know that we are going to get the line of symmetry where x is equal to 3, right? So this is our line of symmetry, and it's actually important all the time. Please make sure that you take this into consideration because it's very important. And also the formula itself, you have to utilize it in order for you to get the line of symmetry. And also, after getting the value of x, you have to think about finding the vertex. So let's look into that. So as we know that the line of symmetry always goes through the vertex, so this means that with the x coordinate that we got, we can be able to find that. So let's look at this particular equation and see how we can be able to find the line of symmetry. So with this, you can see that we decided to go for our b, and our b is positive, meaning that negative b, that would be negative 8, and then our a is negative, and then we're going to multiply that by 2, get negative, and then negative divided by negative will give us a positive 2, right? So you have to be able to plug the value of x into the original equation to find the y value, which is very important. So let's take these two, plug it into the equation, and then after plugging it into the equation, then it means that we are going to get the following after multiplying everything out, and then y will equal 5. So meaning that now as y is equals to 5, it means the vertex will definitely be 2.5, right? So now you will say that you do have the turning point of the graph, and the turning point will be given by 2 for the x value and 5 for the y value. So another thing is that a quadratic function in a standard form will always be, given by this here. So you have to think about that. You have to think about how you can find the line of symmetry, how you can find the vertex of it, right? So let me show you the the equation as the standard form, and also what to expect in terms of finding the vertex, finding, maybe I can say, the turning point, right? So remember, you have to use the equation, or I can say the following equation, just to be able to calculate the turning point, right? And with that, you just plug the x value just to get the vertex of it. So when you are given this equation, you can find the line of symmetry, you can find the vertex, and then with that, we're gonna know that you have the turning point of the graph, right? So let's try to see if we can actually create a table where we can be able to plot the line of symmetry and see how this works, right? So now a quadratic function in the standard form is actually given by 2x squared minus 4x minus 1. If they say find the line of symmetry, or when they say that find the turning point, you have to start with your equation, x is equal to negative b all over 2a, and then you go there and take a and take the b, and then you now know that you have your x, which is equals to 1. All right, so with that, it means that you can go there and plot your line of symmetry. So that will be at 1 here. So it means that this is just 1, and this is 2, this is 3, this is 4. This side will always be negative in terms of the horizontal line, which is the x-axis, and then with y, we're going to have our 1 here, positive 1, and then positive 2 up until the positive infinite. And then down here, it means that y will always be negative, right? So going forward, we can now say that in order for us to get the value of y, we are going to substitute 1 into the original equation and then get the turning point. So that will definitely be negative 3, and negative 3 will be somewhere here, negative 1, negative 2, negative 3. So negative 3 and 1 will definitely give us the turning point somewhere here. And remember that when you are actually dealing with the turning point, you can be able to also get the values of x and y, and then you'll be able to draw your graph. So you you know now that the graph is actually positive here, meaning that this will definitely increment instead of decrementing. So you already know the structure of the graph by just looking at the equation. All right. So now let's say that you have this given, meaning that you can be able to do what? You can be able to plot the graph as given. So now these are actually the values of what? Of x and y, and then you can be able to plot the graph with that. And also sometimes when we talk about maybe y at 0, x at 0, that means that we can be able to know where to find our values. Like for example, if x is 0, it means that we're going to be at -1 and so forth. So let me see if we can have that. Let me see if we can have that. So you have at 0 0, you have -1. -1 is here, meaning that when x is at 0, like here, then y will definitely be at -1. So you can actually solve for x and y for you to be able to continue with the graph and plot it as you know how to, right? So now we just have to take a break, and then we're gonna come back with the quadratic functions again. Welcome back. Now we are going to check the outline. We've already gone through the graphing quadratic functions. So now we're just going to, factorize some equations and also try to deal with the quadratic formulas. So let's get into it. So remember that we were talking about quadratic functions, right? And a quadratic function will definitely get to have an a, b, c in it. And also remember that when y is equals to x squared, or when a is positive, then it means that the graph will just point up. When y is negative, then when this a is actually negative, the graph will go down, and this will be the point of the turning point. And then we know that y-axis will definitely be the axis of symmetry for now, because of how the equation looks like, right? So with that in position, we know that this shape is actually the parabola of your graph, or as represented graph. So we will be able to, let me see if we can have that in place. We'll be able to have something like this at the end, with the turning point, with the x and y values, and this being the axis of symmetry. I've already explained how axis of symmetry works, and that will always be the turning point, remember. So this is how we can be able to draw the parabola through the plotted points, and those points are actually as given. And the axis of symmetry, remember, you can get that by using the equation x is equal to -b all over 2a, right? So then you plot your graph, and then your teacher will be happy. And remember to make sure that you include the values, the y and x values. This looks better than just plotting it without the values, because we'll never know about the turning point, we'll never know about the x and y values and so forth. So this is very vital when you are drawing your graph, right? So let's proceed to the quadratic formula. So with the quadratic formula, remember, if you fail to factorize an equation, you should jump straight to a quadratic formula. This is very important. So then there is the value of a, the value of constant, and also b. So you're done. You can actually have your plus or minus value as given. Okay, let's say that we have an equation that looks like this, right? So with this equation, you think about how you can be able to factorize it, blah blah. You can be able to use the quadratic formula to say, okay, you know what, I do have my values as given, right? I do have 2x squared, then the plus of x, the minus of 5. So remember to take 5 to the other side so that you can be able to get your a and then your b and also your c, right? So meaning that now your c will be -5 and then your b will be 1, and then your a will definitely be d2, right? So you substitute the entire values into the quadratic equation, you are going to get, you know, the final answer where you have -1 plus minus of the given square root. And then you separate them based on these values to say, I need the +1 and also the -1. So this will be the +1 and this will be the -1. I mean the negative value. So this implies that 1 is 1,35, or this can be converted to 1,35, and then we lost some values, you know, we just decided to round it off. We lost some values, so take this as your bank account, meaning that you cannot say that this is equals to this value. That's why they're using this type of equal sign. They're just saying that we rounded off to this, but, or however, there's some values or digits that we lost. Imagine losing some cents in your account or bank account. It means that you're going to lose a lot of money if you keep rounding them off, you know. So let's continue before I talk about programming. So given another equation, so you just have to be able to simplify this one, right? So you have you know, the equation there, and if when you take 5 to the other side, it will be negative, and -1, I mean -x -5 will give us -6, and then -9 will definitely be +9, right? So what do we have here? Is it possible for us to have this in place? So if I say -3 times -3, I'll get +9. When I combine them, I'm going to get -6. So now it seems like we can be able to factorize this, but they were showing you that you can use a quadratic formula if you don't know how to get the factors. So if you don't know how to get the factors, you can just go and apply the quadratic formula, and you find out that the x is equal to 3, meaning that x is equal to -3, like something like this in general. So this will be something like this, -3, and also the other side will be -3. So it's just -3 squared, possibly, if I'm not mistaken, actually. So yeah, this will be it. Yeah, this will be it. It will just be negative, negative. So this will definitely be the +3, right? And then with the one that we have done, we now have one real solution. But I don't know why why we're using quadratic formula, right? But remember, this will give you like 6/3, and then that will be a 3, right? However, they are just trying to say if you have x, which is -3 squared, you'll always have like something like this at the end, x minus 3 and then x minus 3, meaning that this in general will definitely be x which is equals to 3, I mean positive, and then x which is equals to 3 which is positive. So that's actually the real solution, as they are actually equals to each other. So another one that we can look at will be the following, right? And also I just thought of having this because I know that you might ask yourself that how do we solve an equation if there is a less or equals to 0 or less or equal to a number. So we can go and factorize this and say that, okay, what will be the values that when we multiply them we get -8? That will be and when we add them will be positive. The bigger number will be positive, then the smaller number will be negative, so that when we add them we are going to get a 2, which is this one, and then when we multiply them we're going to get a -8, which is this one. And then those are the factors that we have, and then we're going to take them out and have -4, and then we have a +2 as our values. And now with these critical values or x values in a way, we have to think about how we can be able to plot this, because we are using less or equals to up there, just to see how we can actually get to the solution, right? So this is how we can actually get to the solution, by using a number line to say, you know what, the solution will always be from -4 up until +2, meaning that this will be -4 less or equals to x less or equals to the positive. So we are going from negative up until positive. So this is actually the area that we do have as our interval within the given critical values, right? So that's how you can be able to come with the final solution, where you say that x is greater or equals to -4, and then x is less or equals to 2. So this is actually a range, that, okay, this will be our max, this will be our last point of negative side. So this is very important when it comes to programming, just that this is just grade 12, but when you want to do IT and programming, you'll be able to understand this better in the future. So now I just wanted to use the real life example, so with this one I don't really want to squander your time. Let's just end the session, and then we are just going to call it a day. Enjoy your day, and I hope you enjoyed the video.